Per unit converters can be used to convert 277 volts or 460 volts three-phase power to 110 volts. The cost effectiveness depends on a few factors. Firstly, the number of devices you need to convert. If only a few devices need conversion, per unit converters might be reasonable. However, with a large number of devices, the total cost can become quite high. Secondly, the type of converter you use. There are mainly two types of per unit converters available: autotransformers and isolation transformers. Autotransformers are usually less expensive, but they do not provide electrical isolation between the input and output circuits. Isolation transformers are more expensive but offer electrical isolation, which is often important for safety. Thirdly, energy efficiency. Per unit converters are not always 100% efficient. They can lose some power during conversion, which increases your operating costs. Whether using per unit converters is advisable depends on your specific situation. It is important to consider the following. Firstly, safety is crucial. If you are dealing with high voltage devices, you need to ensure that the converters you use are properly rated and installed to meet safety standards. Secondly, the cost needs to be considered. You need to determine the total cost of purchasing and installing the converters compared to the cost of replacing the old devices with new ones that operate on 110 volts. Thirdly, consider future plans. If you plan to upgrade or expand your electrical system in the future, it might be more cost-effective to replace the old devices with newer ones that are compatible with your current voltage. In many situations, replacing older devices with new ones that operate on 110 volts is more advisable than using per unit converters. This generally offers a more reliable, efficient, and cost-effective solution over time. If you decide to use per unit converters, make sure to select reputable manufacturers and products that meet all relevant safety and performance standards. When working with electrical systems, particularly those involving different voltages, it's crucial to understand the implications of voltage conversion and the potential risks involved. A 277-volt system is typically used for lighting in commercial and industrial buildings, offering energy efficiency over lower voltage systems due to reduced current and associated losses. Similarly, a 460-volt three-phase system is common for powering larger equipment like motors, HVAC systems, and other heavy machinery. Converting these voltages down to 110 volts for standard outlets and smaller devices requires careful consideration. Per unit converters, also known as step-down transformers, are designed to reduce voltage levels from higher voltage systems to lower voltage ones. These devices operate on the principle of electromagnetic induction, where a changing magnetic field induces a voltage in a secondary winding proportional to the turns ratio between the primary and secondary windings. This turns ratio determines the step-down voltage transformation. When selecting a per unit converter, understanding the differences between autotransformers and isolation transformers is essential. Autotransformers use a single winding for both the primary and secondary circuits, which makes them smaller and more efficient than isolation transformers for the same voltage and power rating. However, because the primary and secondary circuits are electrically connected, autotransformers do not provide electrical isolation. This means that any voltage spikes or surges on the input side can pass through to the output side, potentially damaging connected equipment and posing a safety risk. Isolation transformers, on the other hand, have separate primary and secondary windings that are electrically isolated from each other. This isolation provides a barrier against voltage transients and noise, protecting sensitive equipment, then improving safety. The isolation also prevents ground loops, which can cause interference and harm in audio and video equipment. While isolation transformers are generally more expensive and less efficient than autotransformers, the added safety and protection they offer often justify the higher cost, especially in critical applications. When evaluating the cost-effectiveness of per unit converters, it's crucial to consider not only the initial purchase price but also the ongoing operating costs. As mentioned earlier, converters are not 100% efficient and consume some power during the conversion process. This power loss is typically expressed as a percentage of the input power and is known as the converter's efficiency rating. A lower efficiency rating means more power is wasted as heat, increasing your electricity bill. To calculate the energy cost of using a per unit converter, you need to know the converter's power rating, efficiency rating, and the number of hours it will be in operation. For example, if you have a 100 volt ampere converter with an efficiency rating of 90%, it will consume 100/0.9 equals 111.1 volt amperes of power from the 277 volts or 460 volt source. The 11.1 volt amperes difference is lost as heat. Over time, this power loss can add up to a significant amount, especially if you have multiple converters operating continuously. Another important factor to consider when using per unit converters is the load they will be subjected to. The load refers to the amount of power that the connected devices will draw from the converter. It's crucial to select a converter with a power rating that is sufficient to handle the maximum load. Overloading a converter can cause it to overheat, malfunction, or even fail completely. The National Electrical Code, known as NEC, provides guidelines for sizing transformers and conductors to prevent overloading and ensure safe operation. When using per unit converters, it's important to follow these guidelines to avoid potential hazards. For example, NEC Section 450.3 provides requirements for overcurrent protection of transformers, which is designed to protect the transformer from damage due to excessive current flow. Similarly, NEC Section 310.15 specifies the ampacity of conductors, which is the maximum current that a conductor can carry continuously without exceeding its temperature rating. When sizing conductors for per unit converters, it's essential to consider the voltage drop, which is the decrease in voltage along the length of the conductor due to its resistance. Excessive voltage drop can cause connected equipment to malfunction or operate inefficiently. NEC Chapter 9, Table 8 provides information on conductor properties, including resistance, which can be used to calculate voltage drop. In addition to safety and cost considerations, it's also important to think about the long-term implications of using per unit converters. As electrical technology advances, new devices are often designed to operate on standard voltages like 120 volts or 240 volts, making them more compatible with existing electrical systems. By replacing older 277 volts or 460 volts devices with newer 120 volts models, you can eliminate the need for per unit converters and simplify your electrical system. This can also improve energy efficiency, as newer devices often incorporate energy-saving technologies. Furthermore, replacing old devices can reduce maintenance costs and improve reliability. Older devices are more likely to fail or require repairs, which can disrupt your operations and incur additional expenses. By investing in new equipment, you can minimize these risks and ensure a more stable and efficient electrical system. If you do decide to use per unit converters, it's essential to select products that meet all relevant safety and performance standards. Look for converters that are listed by a recognized testing laboratory, such as Underwriters Laboratories, known as UL, or Electrical Testing Laboratories, known as ETL. These listings indicate that the converters have been tested and certified to meet specific safety requirements. Also, check the converter specifications to ensure that it is compatible with your electrical system. This includes verifying the input and output voltage ratings, power rating, frequency, and efficiency rating. It's also important to consider the ambient temperature range in which the converter will be operating. Some converters are designed for indoor use only, while others can withstand outdoor conditions. Installing a converter in an environment that is outside its specified temperature range can cause it to overheat and fail. In addition to selecting the right converter, proper installation is crucial for ensuring safe and reliable operation. Per unit converter should be installed by a qualified electrician who is familiar with NEC requirements and local electrical codes. The electrician should follow the manufacturer's instructions for installation, including proper wiring, grounding, and overcurrent protection. It's also important to ensure that the converter is adequately ventilated to prevent overheating. This may involve providing sufficient airspace around the converter or installing a cooling fan. Regular maintenance is also essential for ensuring the long-term performance of per-unit converters. This includes inspecting the converter for signs of damage or wear, such as cracked insulation, loose connections, or corrosion. It's also important to periodically check the voltage and current levels to ensure that the converter is operating within its specified range. If you notice any problems, consult a qualified electrician for assistance. In summary, using per-unit converters to convert 277 volts or 460 volts to 110 volts can be a viable option in some situations, but it's important to carefully consider the cost, safety, and long-term implications. In many cases, replacing older devices with newer models that operate on standard voltages is a more cost-effective and reliable solution. If you do decide to use per-unit converters, be sure to select reputable manufacturers and products that meet all relevant safety and performance standards and have them installed by a qualified electrician. Remember to always prioritize safety when working with electrical systems. High-voltage electricity can be dangerous, and it's essential to take precautions to protect yourself and others from electrical shock. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, and always energize the circuit before working on it. If you're not comfortable working with electricity, consult a qualified electrician for assistance. The decision to use per-unit converters versus replacing existing devices involves a multifaceted evaluation. Factors such as initial investment, long-term operational costs, safety considerations, and future scalability all play a crucial role. When evaluating the cost-effectiveness of per-unit converters, it's essential to conduct a thorough cost-benefit analysis. This analysis should include not only the purchase price of the converters but also the installation costs, energy consumption costs, maintenance costs, and potential replacement costs. Additionally, it's important to consider the potential for energy savings by replacing older, less efficient devices with newer, more energy-efficient models. For example, replacing old fluorescent lighting fixtures with LED lighting fixtures can significantly reduce energy consumption and lower electricity bills. Similarly, replacing old motors with newer, high-efficiency motors can also result in substantial energy savings. In addition to cost considerations, safety is paramount when working with electrical systems. Per-unit converters can introduce potential safety hazards if they are not properly selected, installed, and maintained. For example, using an auto-transformer in an application where electrical isolation is required can pose a significant safety risk. Similarly, overloading a per-unit converter can cause it to overheat and potentially start a fire. To mitigate these risks, it's essential to follow all applicable safety codes and standards, such as the National Electrical Code, and to use qualified electricians for all electrical work. Furthermore, it's important to conduct regular inspections and maintenance of per-unit converters to identify and address any potential safety hazards. When considering the long-term implications of using per-unit converters, it's important to think about the future scalability of your electrical system. If you anticipate expanding your electrical system in the future, it may be more cost-effective to replace older devices with newer models that are compatible with your existing voltage. This will eliminate the need for per-unit converters and simplify your electrical system, making it easier to expand and maintain. Additionally, it's important to consider the potential for technological advancements in the future. As electrical technology continues to evolve, new devices are likely to be developed that offer improved performance, energy efficiency, and safety. By investing in newer technologies, you can ensure that your electrical system remains up to date and competitive. Ultimately, the decision to use per-unit converters versus replacing existing devices is a complex one that requires careful consideration of all relevant factors. By conducting a thorough cost-benefit analysis, prioritizing safety, and thinking about the long-term implications, you can make an informed decision that meets your specific needs and requirements. Remember to consult with qualified electrical professionals to ensure that your electrical system is safe, efficient, and reliable. When evaluating the suitability of per-unit converters, consider the specific application and the devices that will be powered. Some devices are more sensitive to voltage fluctuations and require a stable and reliable power supply. In such cases, using an isolation transformer may be necessary to protect the devices from voltage transients and noise. Other devices may be less sensitive and can operate safely with an autotransformer. Another important consideration is the harmonic content of the electrical system. Harmonics are distortions in the sinusoidal waveform of the voltage and current, and they can cause various problems, such as overheating of equipment, malfunction of electronic devices, and increased energy consumption. Per-unit converters can either generate or exacerbate harmonics depending on their design and the type of load they are connected to. If the electrical system has high harmonic content, it may be necessary to use harmonic filters to mitigate the effects of harmonics. Harmonic filters are devices that are designed to reduce the amplitude of specific harmonics in the electrical system. They typically consist of capacitors, inductors, and resistors that are tuned to resonate at the frequencies of the harmonics. By diverting the harmonic currents away from the load, harmonic filters can improve the power quality and reduce the risk of equipment damage. When selecting per-unit converters, it's also important to consider the environmental conditions in which they will be operating. Converters that are installed in dusty or humid environments may require special enclosures to protect them from the elements. Similarly, converters that are installed in areas with high vibration or shock may require special mounting hardware to prevent damage. Finally, it's important to consider the maintenance requirements of per-unit converters. Converters typically require periodic inspections and maintenance to ensure that they are operating safely and efficiently. This may include checking the wiring connections, cleaning the enclosure, and testing the insulation resistance. By following a regular maintenance schedule, you can extend the lifespan of your per-unit converters and prevent costly repairs. In conclusion, the use of per-unit converters is a complex decision that requires careful consideration of various factors, including cost, safety, long-term implications, specific application, harmonic content, environmental conditions, and maintenance requirements. By thoroughly evaluating these factors and consulting with qualified electrical professionals, you can make an informed decision that meets your specific needs and ensures the safe and reliable operation of your electrical system.